So what we do now is substitute the Cartesian vector notations for A and B and carry out the dot product, and we would get the following: AXI plus AYJ plus AZK. You dot that with BXI plus BYJ plus BZK. That will equal to AB cos of theta. The dot product of these two terms are as follows: AXBX I dot I plus AXBY I dot J plus AZBZ I dot K plus AYBZ J dot I plus AYBY J dot J plus AYBZ J dot K, and it keeps on going, and plus AZBX K dot I plus AZBY K dot J plus AZBZ K dot K, which is all equal to AB times cos of theta. Each of these terms, I dot J, I dot K, all of these terms will go to 0. Those will go to 0, as we previously learned in our calculus course. And all you're left with are this term, and this term. So I dot I is equal to 1, J dot J is 1, K dot K is 1, such that the left-hand side of this general equation is equal to AX BX plus AY BY plus AZ BZ is equal to AB cos theta. So solving for the angle theta, we get cosine inverse of AX BX plus AY BY plus AZ BZ, all divided by the magnitude of the two vectors multiplied together. Section 2.9 dot product, our next objective is to be able to determine the component of a vector that is parallel to a line. So consider a vector, we'll call it vector A, and it could be a 2D vector or a 3D vector. And we'd like to know the component of this vector that's parallel to this line, and we'll call this line B. That's, in essence, what that means is that we want to be able to know the projection of vector A onto line B, and if we can find this length, that is the component of the vector that's parallel to this line B. In order to do this, we have to use equation 2-12, and that states that vector A dotted with any vector B is equal to the product of the magnitude of both vectors multiplied by the cosine of the angle that is between these two vectors. So for this problem, we have vector A, but what is the second vector? And the answer to that is, if we can determine this unit vector along line B, then we can rewrite equation 212 as vector A dotted with the unit vector B and it would equal to the magnitude of A times the magnitude of the unit vector B, U sub B, which is 1, and you multiply it by cosine theta. So if we had the magnitude of A, and if we knew the angle theta, then we should be able to determine this quantity, which represents the component of vector A that is parallel to line B. Objective 2b is to determine the component of a vector that's perpendicular to a line. So we'll use the same setup as before, where we have vector A, and we have that line B, and now what we want to do is find the component of this vector that's perpendicular to this line. Simply, that would be that perpendicular line, and we want to project vector A onto this line. So what we're seeking right now is this magnitude. So again, you use the same equation. Use equation 2-12 is the dot product of two vectors is equal to the magnitude of each vector. You multiply it, and you multiply it by cosine theta. So now what we do is we are interested in this unit vector, U, and we'll just put a perpendicular subscript. So we rewrite this equation for this situation, and we get vector A dotted with the perpendicular unit vector, which is equal to the magnitude of A, and the magnitude of this perpendicular unit vector, 1 times cosine theta. So the component of the vector that's perpendicular to this line B is this length right here, and that's given by this term. So this is the component of a vector perpendicular to line B.